Decatur Tiny House Festival, brought to you by Tiny House Atlanta. We would like to thank our sponsors who helped with the event. This is the first time we've had the event, and hopefully it won't be the last. We'd like to especially thank the sponsors: Whole Foods, Hannah Solar. We have a representative from Hannah Solar here. City of Decatur, and Fontes Water. We appreciate the City Schools of Decatur letting us use this wonderful room with nice air conditioning. They do ask that you do not eat or drink while you're in the building. The restroom facilities are across the street in the festival area. If you do have questions for the speakers and we run out of time, we do have 3x5 cards at the front and back of the room. Please write your contact information and your question, and we'll make sure that the speakers get those. And finally, if you would please take the survey. There's a link here. I'm assuming it'll be on the website as well. We want to make sure that we get everyone's input on that. This is not an evaluation survey, but it is input that Tiny House Atlanta would like to get. But the link is not working right now.
It's currently crashed, so if you'll take a screenshot and find it later, that'd be great.
And the video and the slides will also be available on the website, I understand. So, all right, I'd like to turn it over to a representative from Hannah Solar, Jeff Boss.
Hello, how are you all doing? A little bit about Hannah. We are a full solar integrator. We do anywhere from small utility to residential, based here in Atlanta. We also have an office in Asheville, Greenville, and Savannah. So we are currently in the middle of a Solarize Savannah program for group pricing. So if you have anyone in Savannah that's looking for solar, it's a great deal because you can get about 30% off what the normal install price would be. We have a great panel today. We have Carl Seville. Carl is a consultant, educator, and speaker on sustainability for the residential construction industry. His firm, SK Collaboration, consults on and provides green certifications for single and multi-family buildings. We also have Patrick Chopson. He leads Pattern R&D, a building analytics consulting firm delivering daylight cost and energy modeling services. He is also co-founder of the Energy Lab at Perkins & Will. And we have Robert Reed with Southface. Robert is responsible for Southface Urban Sustainability's practice. Southface has helped Atlanta, Augusta, DeKalb County, and other implement sustainable incentives. Thank you.
So, one more. So I'm Robert Reed. I'm the Director of Residential and Community Sustainability Services at Southface. For those of you who don't know Southface, Southface is a 38-year-old nonprofit established back in 1978 to promote sustainable homes, communities, and workplaces. Southface.
If you're okay, we got a glitch.
Okay. Don't be distracted by the screen. This is not a presentation about your closets. This is about sustainability. So the could be the same thing, exactly. So Southface is, like I said, has been around for a long time. We've got a lot of really great programs. But one of the things that's going on currently is we actually, in collaboration with Tiny House Atlanta, are doing a feasibility study on tiny houses in the city of Atlanta. What we learned, I was responsible for a project called Lampkin Street Cottages back in 2005 or so. For those of you who don't know it, it's in the 4th Ward. It's over behind Highland Bakery at the intersection of Lampkin Street and John Wesley Dobbs. Great little project if you want to go see it. Not tiny houses, tiny-ish. They were about 900 square foot cottages. We call it a cottage community. And that was a very difficult process. We had a willing neighborhood, mostly willing. We had a very excited developer who had done very innovative things before, and we had a city who was willing to take a look at it and see what's going on. Turns out, developer didn't make any money. He sold everything. Fortunately, he got it done before 2008. So he sold it out, but he didn't make any money. So he's never going to do another one. And so we are looking at why is that? What were the inhibitions to it? And what can the city do to promote these things and make it an easier project? And so that's one of the things that's going on. In addition to that, I'm also the president of the American Tiny House Association, which is a very, very small startup organization. We are really, the only thing we're trying to get done is get a national standard for a tiny house, American National Standards Institute standard, so that municipalities like Decatur could point to tiny house on wheels that have been ANSI standard approved and be able to have them be in their city. So that's a long way off, so we're still a long way from that. But those are some exciting things that are going on. Southbase has an Earthcraft program. I think Carl will talk a little bit about this. He'll maybe mention it. No, not so much. Yeah. For those of you who don't know Carl, his internet presence is the green curmudgeon, and you'll get to know why that is in a minute. So I'm going to go ahead and turn it over to Patrick so we can stay on schedule. Schedule. But feel free. My email is a pretty simple one. It's rreed, R-R-E-E-D, at southbase.org. So if you have any questions about the Atlanta process, and we're hoping to get something promoted or before City Council for a few small changes that might make tiny houses easier in the city here by the end of the year, and maybe some bigger ones next year. But if you have any more interest in that, just give me an email and we'll be glad to tell you about it.
And that's City of Atlanta.
That's City of Atlanta.
Howdy y'all. I guess today I'm going to be talking a little bit about kind of big picture ideas behind sustainability for homes, and just kind of give y'all an introduction to some of the really cool technology and things that are out there right now. So I guess I'll just introduce you kind of what I do. Got a little video here. So,
Excuse me, can you raise the microphone? So we
Oh,
can
sure.
hear you? Thank you.
so anyway, just a little bit of flashy stuff. Basically says.
Raise the microphone to your mouth, please.
Thank you. So just basically a bunch of flashy stuff that kind of explains that what we're up to is we're doing a lot of stuff with building optimization, daylight modeling, things like that. That a lot of times when you're doing a home, you really don't think about. So why is sustainability important? I guess all you guys know that since you're here. There's a lot of sprawl in Atlanta, which is driving us to we have too much traffic, a lot of pollution. And so a lot of times everybody's trying to get closer to the city, get things a little bit smaller. So you can kind of see this map here is basically just a heat map of Atlanta that shows where property prices are going up. So we can see that it's kind of blue out here and towards the center it's getting red. So that's kind of a good thing. So I guess a lot of times when we think about designing a home, we think about we want certain features in the house. We don't really think about what's the data behind why we're making these decisions. And that's what's really cool about a lot of things that are going on in the building industry right now. Because when you're an architect, you're trying to basically maximize a bunch of different competing objectives. You want it to be really nice. You want it to have you want it to be low cost. But a lot of times people associate green building with they kind of associate with a much higher cost. But if you're using optimization, if you're thinking about daylight, and if you're trying to balance how much glass you have versus those kinds of things can really make it inexpensive if you use a good process. So I think what I try to do is always talk to people about when you're looking at a house or when you're looking at a building, a commercial building, you're trying to measure how successful it is based on these things. So that total energy is kind of how much energy your house is using on a per square foot basis. Daylight, you can actually measure how much daylight your space is receiving, how much times you have to keep the lights off, things like that. Another big thing is glare. A lot of times maybe you're working in your living room, you got all this light shining in your eyes and you have to move to another space. That's an example of glare. And then the one that I think anybody who's worked in an office building will know that thermal comfort's a really big problem. And then cost. To me, I love sustainability. I love this idea of being a good steward of our planet, but We do live in a world where things cost money. And so I think it's really, really key if we can try to keep the cost of all these things balanced. So how do we do that? Well, there's really only 4 things you have to keep in mind when you're laying a house on a site, or even in a commercial building. It's like you got shading, how far the roof comes over, if you have any projections that come out over, glazing, in terms of like how much glass you have, which way it's turned, and then schedules. And I think like this is really the thing. I have a nest here because most people associate that with like controlling the temperature of your house, but that's really the major thing that is really driving how much electricity that you're using in a house is like, when's the thermostat on, when it's off. A lot of people don't realize you can modulate that. And then here I have like some examples of tiny houses where we tried different layouts of the house and rotate it different ways and compared what the energy use was. So energy per square foot is what this is being measured in. You can see how little changes can make a really big difference. Also, these are like a daylight map, so you can see how this is like a floor plan for a tiny house, and then we also have a different kinds of windows. So this is like the front of it, and this is the floor plan. And you can see how just a change in what kind of window you have makes a really big difference in how the daylight passes through the space. So this one right here is the most even, and these are the ones with the most dark spaces in the back. Another thing is thermal comfort. You can actually measure in a space like what point. So imagine, how this room has little floor tiles everywhere? Well, each one of those tiles, we can measure that and say like, standing here, we're 90% of the time we're satisfied. Near the window, maybe we're 70% satisfied. You can actually measure that, and that's really cool things that a lot of like really modern architects are doing now, trying to understand like how comfortable people will actually be in a space. Another thing is glare, and these are like little glare maps. So it's like you take a camera and a computer program and you say like, how much of the time is this person going to get glare in their eyes? So that's like another thing that's kind of going on. Also, we do a lot of stuff with optimization, and one of the things that's really cool is you can actually, there's like maybe a universe of 1 million options out there of things that you could do, but a lot of times we have to rely on past experience to measure that. And so we actually run like 1,000 simulations, and then we come up with optimized groups of technologies like windows, wall configurations that work well together. And so I guess what I kind of wanted to share was just some things that we have found that based on our optimizations are generally true about Atlanta. So for example, I don't know if you all have been around Atlanta a lot lately, but you've seen like a lot of buildings with this green board on the outside. And basically what that is they're putting like insulation on plywood, and then they're using that with tape. It's called a zip system, but it's something that if you're building a new house or a tiny house, like it's a really good thing to look into because it actually means that you can have like a completely sealed envelope. And then if you balance that by building with 2x6 construction, instead of 2x4s, and you put that 24 on center, you can actually start to put things like having a house that's more insulation, less wood, and it's actually a stronger house. So if you're talking to a builder, ask them about this thing called advanced framing. And it's not really advanced, it's been around since like 1900, but things go slowly. So then another thing to kind of keep in mind too is like what kind of air conditioning system. If you guys go outside, you're going to see a lot of ductless mini splits if you go to the actual booths out there, and that's really good if you can afford it. But if you can't, if you're balancing, some of these options with how much glazing you're putting, you can still go with like a regular heat pump and still be okay. But like I said, if you got a little extra budget, the ductless mini split is even better. Another thing too is a lot of times people think about for a house, like maybe we should have this hot water, instant hot water heater. Sometimes those things take up a lot of power and really fast. So what I always tell people is, if you're actually getting into, a slightly more higher performance water heater, just a regular one, you can, with a system that circulates the water through the house, you'll always have that hot water right there instantly, but you'll have to spend up a little bit less on energy. Another thing is like occupancy sensors, like those are another thing like too, like with the Nest systems and other things out there, you can tie that all together so you can have a house that's kind of becoming intelligent and it only turns on when you're in the room. Another thing, of course, Nest, we all know about this, but some of the times, like, if you don't set them up right, they can just keep turning on, you keep turning them off. So it's important to kind of like really understand like what they're there for and try to train them to do what you want them to do. And then also using LED lamps in your house, like it used to be maybe 5-6 years ago that was like way too expensive to put LEDs everywhere, but the price has really come down. And so you can get really good color rendition with just like a regular bulb. Also, so I was talking about circulating the water. So like, a lot of times builders today are putting little circulation pumps in their hot water supply that run the water through continuously, so you always have hot water. But it's just another way to kind of save a little bit of energy by not having an instant hot water heater. And then one of the things that there's like a cost curve right now for like PV, that like basically if you're putting photovoltaics on your roof, like in Georgia, last I checked, and maybe other people can speak more to this, 2017 is becoming even a time where you don't need a government subsidy for solar power in Georgia. So I think there's a lot of really cool things with that as well. Just to keep in mind that like the price of all this stuff, maybe a few years ago when you maybe first Googled it, you were like, oh, I really want a sustainable house, but it seems so expensive. It's actually, things are becoming a lot more affordable. So I guess in the interest of time, I'll kind of like cut to here and we can have Carl talk a little bit more. But if you guys got any questions about like specific things to your house or things like that, feel free to come over and talk to me or fill out a card. Or I got some brochures kind of scattered around, so if you guys pick one up, give me a call. We do a lot of design for houses in Atlanta. We also consult to other architects, so we actually help other architects be green as well. So if you all are interested, just feel free to talk. And if you got any questions about your house, I'll be happy to answer that. What's that?
Hey, I'm Carl Seville. I'm a recovered contractor. I spent about 25 years renovating houses in Atlanta and finally got out before the economy collapsed. And now I do green building consulting. Primarily I work on certifying single and multifamily homes. I'm doing a lot of stuff in Decatur actually, as well as most of the eastern United States. It's sort of a technical talk. I'll try and keep it as high level as I can. It's essentially, this will apply to virtually any house, and I've tried to like dug in a little bit in terms of what will make sense in terms of how it relates to tiny houses as well. So the goals for a house or a tiny house: you want it efficient, healthy, comfortable, and durable. You want to not spend a lot of money and energy. You don't want to get sick in it. You want to be comfortable. You talked about thermal comfort. You don't want to have to move away from the windows if there's too much sun shining in, and you want it to be durable. You don't want it to rot. You don't want it to fall apart. Just grab a little picture of a tiny house on the right, and this actually is my house. I live in a small house right now. When it was built, it was 400 square feet. When I bought it, it was 750 square feet, and I just enlarged it to 800 square feet. It's actually going to be the accessory building for a new house that I literally just started this week, which is going to be 2,600 square feet in front of it, because I recently got married and we both work at home, and 800 square feet is not going to work for 2 people with home offices. But I've lived in this 800 square foot house for about 11 years now, and it's actually more space than I need. It's kind of, I use it, but it's a comfortable house, a spacious house. People can't believe it's only 800 square feet. I'm not sure I'd want to live in a 250 square foot house, but there's a lot to be said by it. So the way we get to a high performance house is by building science. I'm going to give you 20 years of building science in about 10 minutes, so hold on. Building science is the interaction of heat, air, and moisture, and everything interrelates. The way heat and air go in and out of a house affects the moisture and such. Heat always moves from hot to cold. It moves 3 ways: through conduction, convection, and radiation. Conduction is through a solid. Convection is through air movement, and radiation is from surface to surface. Anybody want to guess how we control each of these? Anybody have any ideas? Any thoughts? Insulation controls conduction through the walls.
Fans.
Pardon?
Fans.
Fans actually will cool you by convection, but air movement is stopped by air sealing, caulking, tapes, things of that sort. And then radiation is generally from windows and sometimes from roofs. So using high performance windows helps cut down the radiation. and radiant barrier sheathing or reflective roofing helps cut it down. So we're basically looking with insulation, air sealing, and cutting down radiation to a house. Those are the three ways we're going to keep the house warmer or colder depending on the season. So in terms of air movement always moves from high to low pressure. It doesn't do anything else. This is just physics. It only goes through holes. So if you theoretically had a house that had no holes, there would not be any air movement, period. And our goal when we build high performance houses is to make them as tight as possible. There's this theory out there that homes should breathe. It's a lie. Homes should not breathe. Homes should be as leaky as a submarine. That's what you want. And then you intentionally ventilate it. And in addition to the holes, it has to have a driving force. It has to have wind or ducts, in case of fans, HVAC systems. So if you have holes but no driving force, no wind and no ducts moving around, you don't get air movement. If you have a driving force and no holes, nothing happens. So you have to basically seal up all the holes and manage the driving forces, because you can never seal the holes perfectly. So you want to limit the driving forces that will push air through the house. This diagram here I want you to pay attention to it because it explains an amazing amount of things. And we're using a sheet of drywall here as an example. We're starting here, heat moves through the air. When the heat moves through the air, there's either heat gain or loss, depending on which way it's moving. If it's cold outside, you're going to have heat loss inside. If it's the other way around, just the opposite. So less air movement gives you much better temperature control and improved comfort. You've probably all lived in a house that's kind of old and leaky, and when the temperature drops outside, your house gets cold really fast. When you live in a very tightly air-sealed house, the temperature can drop outside, and your house will hold this temperature for days. There are people I know who build houses that are very well insulated and very tightly air-sealed in Colorado that don't turn their heat on for most of the year. They only turn on the most extreme cold. So think about that. If your house gets cold or hot really quickly, it's, in addition to insulation problems, it's got air leakage problems you have to control. So the bottom half of this, vapor moves through air. That's where this diagram comes into play. Air movement transports vapor with it. And the problem we have in our climate in particular is in the summertime, it's really humid outside. So when you're running your air conditioning, the air conditioning cools as well as dehumidifies inside the house. If your house is really leaky, what happens is all that humid air outside finds all these holes and it goes, hey, it's dry in there. Moisture always moves from wet to dry. So you air condition it, dry it out, and all that moisture outside go, let's go inside, and it runs inside your house and your air conditioning works harder. So if you air seal your house very well, your air conditioning cools the house, dries it out, and it stays comfortable much longer. And the description of this is if you take a sheet of drywall, plywood, OSB, it's all about the same. Through one season, through one heating or cooling season, if there's no holes in this sheet, it will diffuse 1/3 of a quart of water. It's minimal amount of moisture goes through as vapor. If you cut a 1-inch hole in that sheet, you get 30 quarts of water moving by air movement. Think about how small a 1-inch hole is. Think about how many 1-inch holes you have in your house. The average house has about a 3 by 3 hole in it. That's the average house the way it's built. So think about how much moisture is coming in and out of your house. So finding the holes and sealing them is really important. So you cut down the vapor, the air movement, you get less vapor movement, better humidity control, cuts down mold and mildew, keeps the house more comfortable. And there's a bonus. When your house is really airtight, it's cleaner. You know how when the sun shines in a west window, you see all those flakes of things floating around in the air. When you have a really well air-sealed house and you take care of things on the inside, like if you have pets, you keep them clean, or you don't have pets, you don't wear shoes in the house. An air-sealed house, that stuff just doesn't come in. Those houses are much cleaner. I had clients when I was renovating houses, after we insulated and air sealed them, their allergies went away. Literally, they disappeared. You don't make those claims because I'm a health professional, but this is what happens in high-performing houses. So moisture movement's always wet to dry. You got to do with rain. Rain comes in by gravity, capillary action, which is sucking in through small holes, and then momentum, which is going to be driven in by rain. So you have to make sure your house is well moisture sealed. And then we talked about humidity, the vaporous humidity that comes in and out of cracks. Okay, that's my building science lecture. So back to the real world. How do we control that heat, air, and moisture in a building or in any house or a tiny house? We control heat with insulation and an air barrier. I call it the 3 C's. They have to be complete, continuous, and in contact. Insulation that does not have an integral air barrier needs an air barrier in contact with it, or it does not work, period. You can locate that air barrier on the interior or the exterior or both. In a standard house, you've got your exterior sheathing, which is an air barrier, and your drywall, which is an air barrier, and your top plate and your bottom plate, that's the air barrier that controls it controls the air movement through the insulation, and the insulation then works. In terms of types of insulation, there are air permeable insulations, which absolutely have to have separate air barriers. Fiberglass, cellulose, mineral wool, and people like green buildings like denim insulation. It's got its limitations, but it's these things, if you don't put an air barrier with them, they don't insulate. Air impermeable products don't need a separate air barrier. That's open cell and closed cell spray foams and rigid foam boards. So whether it's combined or separate, insulation has to be put together with an air barrier, and then you have to seal all the leaks around it. So I put this in there, controlling air movement in and out of a building. I came up with this concept for a presentation recently. It's just geometry. It's planes, lines, and points. That's really all it is. So the planes are the floor, the walls, and the ceiling or roof. And those are pretty easy. They're generally sheets of plywood, OSB, things of that sort. The lines are the seams. That's where the floor hits the wall. It's the joints where the ceiling hits the roof, and where the wall hits the ceiling or the roof, and where the windows hit the walls, and then also the seams between all the sheets you're using. So every seam, any place two materials meet, you have to seal that seam. It is absolutely critical. And then the points of the holes, pipes, wires, ducts, anything that goes through that air seal has to be sealed around it. And this is the thing I see the most, is that contractors in general don't seal these things. They are not well air sealed, they're not well moisture sealed. So that's basically, you have to look at all those things and figure out, just like, think about how's air getting into this house, how's moisture going to get into this house, how do I close up those gaps? So in terms of walls, floors, and ceilings, a typical house, you have OSB or plywood on the outside. You might use foam board on the outside. And then in most houses we use drywall, but we notice in a tiny house, there's not a lot of drywall. Most tiny houses have paneling. The interesting thing about paneling is there's a seam between every single piece of paneling. So what does that mean? Lots of holes. So if you're going to air seal your tiny house, you have to figure out a way to do it. You might want to do it on the outside with rigid foam. You might want to do it with spray foam on the inside. You might want to put some kind of maybe drywall before you put the paneling in, but you need to figure out a way how to air seal it. And I haven't tested these tiny houses. I gather some of them are have a little bit of air leakage because of the paneling. It's just a guess. So that's the flat areas. The planes, we have to use those materials to seal them. The seams, you can use caulk, you can use foam, and you can use tape. And you mentioned Zip Sheet there, got some pictures of that too. It's a great product. And then the holes, same thing, caulk, foam, and tape. To basically seal every hole. Just look for every place where a plane has a penetration or a seam, and they have to be sealed. Moisture movement is also really important. And flashing windows, which I'd say 50 to 70% of the time most contractors do not flash windows properly. Flashing around pipes and wires, same thing, people don't do it properly. And you have the air seal and the moisture seal are often not exactly the same. You have to seal for both, because insulation is interesting stuff. It works great, it keeps houses comfortable, but it also retains moisture. Houses that were built in the 20s with no insulation tend to last forever, because water gets in, water dries out. When you have a house that's insulated, and most of our houses are now built with composite products, which a friend of mine refers to as waswood. Used to be wood, got ground up and rebuilt together. Like OSB, like I-joist, it's waswood. When that stuff gets wet, it rots. So if you don't perfectly seal the outside of your house, when moisture gets in, it will rot, it will mold. So this is the other piece of it. Controlling moisture movement, and in most cases that controls air movement. Zip sheathing, as we mentioned. This is a great moisture barrier and an air barrier. The only downside is you have to make sure you put the tape on right. It's everything else. If you do it right, it works fine. Foam board and house wrap is typically used as a weather barrier. It used to be referred to as an air barrier, but I think most people have kind of given up on that. So that would have to have a separate air barrier to it. So where are we in terms of your tiny house? Your house is now insulated, air sealed, it's moisture managed. What's left is mechanical systems, heating and cooling, and ventilation, and then other stuff, which we'll talk about briefly. So, Patrick mentioned mini split heat pumps, and I did notice that pretty much every tiny house has a mini split heat pump. They are absolutely terrific. They're variable speed. They dehumidify beautifully. They're incredibly efficient. They're incredibly quiet. They're slightly higher cost than alternatives. But the great thing about them is they work at a lower outside temperature. If anybody's ever had a heat pump for their heating system, you know that standard heat pump, when it drops below about 40 degrees, it goes into toaster mode. It basically turns on this strip heat. And it's not very hot and it's not very efficient. A mini split, these are designed to pull heat out of the air down to 0 degrees. I have these in my house. I have one of these heats and cools my house perfectly down to 0 degrees outside. We don't get too much. So this is the other alternative for the mini split is like a package terminal heat pump. It's essentially like a window air conditioning unit. They're noisy. They kind of go on and off. They go on and off. They blow hard and they turn off. And probably the best example I have of the difference between a single speed and a variable speed system. The mini splits are variable speed. I was at Grindhouse Killer Burger one day a couple weeks ago, and I'm sitting under the air conditioning ducts, and it turned on, and it's blasting cold air on me, and I was freezing, and it turned off, and 5 minutes later I was hot. And that's the downside of a single speed heating and air conditioning system. When you have a variable speed system, my system in my house, that's one of them right there, it just moves very slowly. You barely ever hear it running. It just kind of continuously runs and heats the air. It's kind of, like ramps up a little bit if I need more heating and cooling, ramps down slightly. It is, for a small house, it's absolutely it's really the only way to go. There's nothing else that makes sense for a house below 400 or 500 square feet. Ventilation is really critical in close quarters. I would imagine most people want to live in small houses, and I tend to do this, open your windows and doors a lot, but there are times a year where you just can't do it. When you have a very tight house, you have to ventilate or the air will get stale. Cooking, breathing, bathing, cleaning products you use, most furniture pollutes your house terribly. We probably shouldn't buy anything but hardwood furniture because between the foams and the fabrics, they're terrible things. In any case, they're all pollutants. You got to eliminate them, and you eliminate them by being careful what you bring in the house, both in terms of building materials and furnishings, and shoes, and pets, and frying turkeys, and whatever else you do in a house that might pollute it, you want to get rid of it. And then what you can't get rid of, you have to ventilate out. There are two types of ventilation. There's spot ventilation, which is basically exhaust in kitchens and bathrooms, which you should use. And again, tiny house or no, you should always run your bath fan for 30 to 45 minutes after a shower. If you don't do it now, just start. It's absolutely what you need to do. If not, your house is going to be a mess. And you should always run your kitchen exhaust fan when you're cooking. If you have enough gas heat, when you turn on the gas heat, an enormous amount of moisture comes in the house. When you start cooking oil, formaldehydes and all kinds of other pollutants come out. So you should absolutely run your range hood vent. And your range hood should vent to the exterior. If it vents to the interior, it's just noise. The other piece is whole house ventilation. You may need some kind of continuous ventilation. I was talking with a friend of mine who actually is driving around the country on a tiny house tour right now. I didn't put the website up, but it's called the Proof is Possible Tour. He's kind of a character. He does tons of videos. I would definitely check it out. It's just the Proof is Possible website. You'll learn all about it. And we did communicate a little bit about this, and he said he's struggling with the ventilation in his tiny house. He, his wife, and a baby in one of these tiny houses. You can do supply ventilation, which would basically be sucking air into the house just to kind of pressurize it. You can use exhaust ventilation, and a lot of times you just use a bath fan, which runs continuously at about 20 cubic feet per minute. It's a low speed, and then you turn it up higher. That's probably a good solution for a tiny house. The other alternative is balanced, which is called an energy recovery ventilator or heat recovery ventilator. It's this big box with this little magic coil that takes the heat and humidity out of the good air and moves out of the bad air and moves into the good air. There's some small ones that would be very appropriate for a tiny house and give you really excellent ventilation. There are some climate issues. You don't want to necessarily have a lot of supply ventilation in a really humid climate because it can kind of suck moisture into the walls. But ventilation is one of the most talked about, argued about, and complained about issues in building science. So people will be talking about this for 20 more years. But just keep in mind that you have to have some kind of ventilation to make sure your tiny house stays healthy. Water heating, depending on whether you're on a foundation or on wheels, you want to look at, is you need it with propane or electric. Patrick mentioned tankless water heaters. Electric tankless water heaters are a real challenge. They use an enormous amount of power, and they don't have a real good reliability. If you're not mobile, you can use natural gas. I'm not actually sure what most of these tiny houses are doing out here, but I would think propane with a small tankless heater would probably make the most sense, unless you have room for a heat pump water heater, like you mentioned. The problem with a tiny house, you don't have much room for a full-size water heater. If you have a tank heater, there's the capacity. You might be able to get away with a little 10 or 15 gallon electric heater. It's not super efficient, but it might be the best solution for you. And tankless heaters, there's this whole temperature rise issue. If you get really cold water coming in, a tankless may not be able to give you the temperature you need. And again, if it's electric, you have serious electrical requirements with your tankless heater. Lighting appliances, we talked about LEDs, they're slowly taking over CFLs. There's no reason at this point to put anything but LED lights in your house. They're inexpensive enough. Cooking, you want to cook with propane, you want to cook with electric. Probably the best solution now is to look at induction cooktops. They make very small, all sizes, but induction cooktops. They're electric. They do not get hot. They're kind of vaguely like microwaves. They heat steel pans. They're the most efficient, and you can actually have perfect temperature control. You can hit it to simmer. It simmers immediately. You can boil water in like 3 minutes. It's really impressive. And the other thing you want to think about in terms of efficiency is phantom loads, which is just, we refer to them as vampires because they always suck electricity. It's like all those little lights you see in your house on every piece of electronic equipment. Some of them can be kind of high. I think routers, cable boxes, things like that. You just want to think about how much energy am I using, what makes sense, how can I turn it off. So I have a switch in my office that I turn off quad receptacle. It turns off all my office equipment when I leave the office. So I'm not leaving my printer on, my computers and my monitors on all night. It's easier than turning everything off. And then heat gain, you mentioned that you had a really good point about the comfort level. Heat gain in our climate can be a real challenge. Our climate doesn't get that cold that we have to worry too much about heat loss through windows, but heat gain through windows. Unshaded south-facing windows and west-facing windows can blaze sun into a house and raise the temperature dramatically. I've actually been in houses, standard houses, that had too much glazing, and when it was 60 degrees outside, they needed the air conditioning running because they didn't control the glazing very much. So you need to make sure that the glazing is controlled so that you get light and heat when you want it and don't get the heat when you don't. So in terms of, just to recap, we're going to insulate, we're going to air seal, we're going to manage the moisture, we're going to pick the right mechanical system, and what it gives you is efficiency, comfort, durability, and health. And there's my contact information. My blog is greencurmudgeon.com. I'm actually going to be blogging about the house I'm building now, so you can follow it and argue and complain. Feel free to tell me what you don't like about it. And I guess we've got time for questions.
I'll take a couple of questions. He didn't sound as curmudgeonly as he really is, so get up here and ask him about vapor barriers. So,
Oh, actually, wait, I had one other point. Patrick made a really interesting comment about the cost of high performance. And I constantly hear this complaint that high performance, or green for lack of a better word, costs more. The problem we have is the baseline of construction. Okay, here's some curmudgeon stuff for you. The baseline of construction is incompetent and illegal. Virtually everything out there doesn't meet the energy code, barely meets the building code, and in most cases does not meet the manufacturer's recommended installation instructions for insulation, HVAC systems, etc. So the industry is fighting against illegal incompetence. If we could get the base level of construction up to following the code, not making stupid design decisions, and following the manufacturer's instructions, we would have green building everywhere. That's the challenge. That's why green building costs more, is because everything we're getting is garbage.
Yeah, I'll second that motion too, because like I was out at a house that we're working on, and these guys had built the house, and they had like a circular saw, and they were just cutting windows wherever they wanted to, and I had to like say, guys, you got to follow the plans. But like sometimes people get real creative on the job site, and their creativity is not things that are appreciated. So, but really installation and air sealing and all those things that he was talking about are really, really, really important. And if you can find a good contractor who really understands that, your house is going to become high performance, and he's just doing his job right.
So you ready for another curmudgeonly question? Right. So Carl and both Patrick mentioned mini splits. So mini splits have, for those of you who don't know about them, they basically have no ducts. They're called ductless mini splits because the only thing you have is freon lines running to the outlets, and the outlets have the blowers integral with them. So most of those of you who have traditional houses, traditional split air conditioning systems, will see the flexible duct pipe running everywhere. So talk a little bit about why that would be inappropriate for a tiny house in particular, and what the manufacturers say about installation of flex duct.
Well, in a tiny house, you don't have room for ducts. And the other important thing to think about is that in typical houses, the ducts run to the exterior. I guess this is the HVAC duct right here. They run to the exterior because in older buildings, there tends to be a lot of heat gain and heat loss at the exterior. But in a high-performance building, you don't get that much heat gain and heat loss, so just feeding the supply from anywhere generally works fine. Like I said, I have an 800 square foot house, and if the doors are all open, one mini split handles the whole thing. And if you have to put ductwork in, going back to sort of a standard house, is there has to be room for the ductwork, which architects and contractors tend to not leave the space for it. And flex duct can be twisted and tied into knots and squeezed into places where it basically doesn't even go, the air doesn't get through it. If you have flexible ductwork and you install it straight and stretched and support it at 4 or 5 foot intervals, and there's room for it, it's not crushed and twisted, it works fine.
So how many people have in their attics flexible ductwork as he described in the knots, right? So this is something to look for, obviously, for your own houses currently, but when you move into a tiny house, the mini split, one of the things we've done at South Base, we did some modeling similar to what you were talking about on the amount of air conditioning loads in a mini or a tiny house, a model tiny house. And the air conditioning and heating loads are so small that a traditional split system where you have ducts and blowers is too big. You would never get the humidity out. It would just not work at all. And so we modeled several sort of through the wall air conditioning systems, PTACs.
They're probably too big as well.
They are, and the problem is mini splits are even on the borderline of too big. And this is a fairly big tiny house. This is a 400 some odd square foot house. So the lesson was that the mini split, because even though it's too large, runs at a variable speed, it's the only one that's actually going to deliver the energy efficiency that you're going to be looking for. Now, go ahead.
Can I interrupt just
Please.
for a second? I'm gonna pull this display. We've hit past what the fire marshal is comfortable with. So with the next presentation, we're moving over to the extra gym. I'm gonna grab this, so you guys keep talking, but we're gonna get it set up for the next one.
All right. So everyone look where the exits are. 2 on your left. File orderly out when the time comes. We'll be wrapping up here soon. I'm gonna get to your questions in a moment. I did want to point out, you speak about the importance of high performance materials. Great thing about a tiny house is that you have much less of them, right? You have so much less materials, you can actually afford the high performance materials. What are some of the things that you've seen that work? I know we mentioned zip, we mentioned radiant barrier. What are some of the other high performance materials that you've seen that are definitely worth the money?
So one of the things that I've found is that definitely, even with conventional construction, if done right, and with a continuous insulation from like a zip system or something like that, I find that that is a way to save a lot of money and still get the high performance things that you've learned too.
Yeah, like rigid insulation, continuous insulation, sometimes spray foam insulation. Truthfully, almost anything on the market installed properly is fine. It's like, people always think about what are the green materials, or what are the high materials, but it's not the materials, it's the workmanship. There are very few products that will not fit into a greenhouse if they're done right. And even the greenest materials or highest performance materials, if done wrong, won't work, and they will not improve the house.
Last thing, then we'll get to y'all's questions. You mentioned vapor coming through the wall being very important for vapor to be blocked. Why shouldn't you put sheet plastic in the wall?
Oh, you don't want to ever use a vapor barrier, because if you have sheet plastic in a wall, which people did for a while, but they finally gave up on it, when any moisture that does get in the wall, and some moisture is always going to get in the wall, when the air conditioning runs, it's going to condense on the plastic and rot your walls. So you never want a vapor barrier. Theoretically, there's a line. In the north, you sort of want one, but they're using so much air conditioning, you really don't want it there either. There's a line that actually runs through Atlanta, and above that line, you're supposed to have a vapor retarder on the inside, and below that line, you're supposed to have a vapor retarder on the outside. So in Atlanta, if you want a vapor retarder, you have to take it out and move it to the opposite side of the house each season. So I think you're better off not having one.
All right, so we'll look for y'all's questions now.
Yeah.
In the middle back there.
Is this zip system you're talking about, is it a moisture and an air barrier?
Yes, it's a weather, zip system is a weather barrier and an air barrier, and you guys know what the zip system is.
Right. And so just to be clear about the zip system, what you're seeing on the zip system, and there's a couple different options. What you normally see is oriented strand board with a green applied air barrier to it that then accepts that tape that helps create that barrier. And that paper, the green that you see, is the
It's a weather barrier.
weather barrier. And what sometimes you'll see is the brown zip, which can be roofing underlayment, but there's also a zip system which is OSB board and insulation. And that's really the upgrade that you're going to be wanting to look for, because what that does is prevents some of the whatever temperature differential you've got from hitting the studs on the outside. Because studs, even though they're wood, do conduct more than insulation. And so there, if you took an infrared picture of a house that doesn't have insulated sheething on the outside, you can see where the studs are because they conduct a little bit more than the insulation. So here in the middle, who had one?
How about with total coating outside of
I was actually going to ask that question. What about this this paint that promises to block 100% of the?
It's magical. It's
Magic.
a unicorn.
It's a unicorn. It doesn't exist. So don't believe the whole hype about the paint that blocks 100% of radiant. It does knock out a good amount of the radiant heat, but as Carl was explaining, there's 3 different ways for heat to get through the house. Middle here.
When you talk about the zip system, how is that different than the tieback and the house wraps that came out like 10 years ago, 15 years ago?
Yeah, tieback is like rarely installed properly. It's very leaky, and it's just really hard to install properly. So most of the time, it's not installed right. Whereas the zip system is a lot easier to get it right.
And the house wraps, the tieback, essentially aren't really an effective air barrier. Well, the zip system is an air barrier and a weather barrier together.
You can see those all the time. You go around, you see the bottom of them flapping in the breeze. That's where the air goes when if they're not sealed properly at the bottom. We got time for 2 more questions. Maybe your gentleman over here.
Carl,
Mark,
bad inspectors. So how do you make sure that your house gets built properly if you can't rely on the city or county building
you
inspectors?
shelter me. You get it certified. Actually, Decatur now has a green building ordinance. Every house in Decatur has to be certified under a green building program. And you hire people like me to do the certification and inspect it and make sure the work's done right.
Ma'am?
Yeah,
Last question.
could you speak about SIPS panels? I mean, is that, I mean, is that similar to, because you've got some of them have.
SIP are structural insulated panels.
Yeah.
Go ahead.
Yeah, so SIPS panels are really good, but you'll see sometimes there's people going around Atlanta that say, I can build a super efficient house with steel beams with SIP panels between them, and basically you've just taken all the advantage out of that. So what you want is you want it to be built with the SIP panels only and no steel in there.
SIP is an ice cream sandwich. It's got basically foam in the middle and OSB on the sides. And it's structurally sound, continuous insulation. It's a great product. It tends to be on the pricey side, and it's maybe a little bit of overkill for our climate because we have a fairly moderate climate. It's terrific in really severely cold climates.
One last thing. And so those of you who may be considering using containers, shipping containers to build your tiny house, if you're planning on doing that, you have to have insulation on the outside. So that exterior corrugated siding that you see exposed is actually against energy code. Energy code requires there to be insulation on the outside, so you have to you can use it for the structural elements, but you have to put insulation and some weather permanent or weather resistant sheathing or siding on the outside. So thank you all for coming and look forward to more questions.